The next situation we want to look at is if we have two triangles. And two triangles is going to occur when we meet two criteria. The first criteria is, can we complete a triangle? In other words, is the side opposite the angle I'm given greater than the h value I find? So I still need to find that h value and do a check. The second thing we look at is that the side must be less than the adjacent side. So there's two parts that we're looking at here if we're going to have two triangles. First of all, the height has to be acceptable to complete the triangle compared to the side that I'm given. The second thing is that opposite side has to be less than the adjacent side. So I'm always going to do that test for h first. So looking at my values I've got here, angle B is 20 degrees, side B is 4, and side A is 7. So what I'm looking at here is I've got angle B and I've got side B, and I'm going to be comparing that to H. So first thing I need to know is side B long enough to complete the triangle? And once again, I'm going to choose side B because it's directly opposite the angle measure I'm given. So H is going to be A times the sine of B. I've got to use the other side that is not across from the angle. So 7 times the sine of 20. And we'll plug that into our calculator. 7 times the sine of 20 is going to be 2.394 units. So this right here is going to be the minimum height to complete the triangle. So I look here, okay, 2.394. I've been given 4 units to work with, so yes, I can complete the triangle. So I'm going to draw a very quick sketch of this triangle. So here's my angle B, which is going to be 20 degrees. Side B is going to be 4, and side A is going to be 7. So I know I've got at least one triangle. The question is, do I get two triangles? And now we've got to do another check. We got to check, are we less than the adjacent side? If I look at 4 here, it's definitely less than 7. So I am going to end up with two triangles that I've got to solve. So this is my first triangle. The second triangle that I come up with is if I were to have drawn side B coming inward. So right now I went with side B going outward. What would have stopped me from drawing side B coming in like this and then saying that this piece around here was my triangle? So either the triangle is going to be big triangle here, or it's going to be this blue triangle here where B equals 4. So you can think this angle right here, we don't know what it is. It's not a fixed angle. It could be an obtuse angle, which is going to be going outward, or it could be a small acute angle. We don't know what that is, but I do know that this length of 4 does complete a triangle here, or if the length of 4 goes out here, it completes this big triangle. We once again don't know this side. We don't have that angle being locked down. So it is fair for me to say I have two potential triangles given this angle side situation. So once we do that, we need to be able to solve out the triangle. And I'm going to draw this on a separate sheet of paper so we've got a little bit more room to work with. So the first one is going to be triangle 1. And triangle 1 is this triangle that I drew. So you've got angle B is 20 degrees, angle A is equal to 7, side B is equal to 4. And when I solve this triangle, it's going to be just like we've done before when we solved out these triangles using sine of A over A equals sine of B over B and all that stuff. So here for this one, we'll start with the sine of B over B equals the sine of A over A. Got to start with that since those are the pieces that I'm given. Sine of 20 over 4 is equal to the sine of A over 7. Cross multiply, solve, and then we'll take sine inverse. And we get that angle A is 36.765 degrees. So this right here is 36.765 degrees. We can then find angle C, which would be up here, and then we can find side C. So angle C, we'll use the fact that there's 180 degrees in a triangle, and we'll subtract angle A from angle B. So 180 minus 36.765 minus 20. So angle C will be 123.235 degrees. So this up here would be 123.235 degrees. And then finally, we'll do the sine of C over C is equal to the sine of B over B. And once again, I used B's because those were my originals I was given. So the sine of 123.235 over C is equal to the sine of 20 over 4. Cross multiply and then divide by the sine of 20. And we get C is equal to 9.782 units. 9.782 right there. So now I've solved for triangle 1. I need to do the exact same thing now for triangle 2. So I'm going to do triangle 2 is going to be in the blue. So I said, what happens if I were to have drawn my side coming inward? So B is equal to 4. Well, I can see right here I've got to find this angle, this new angle A. I've got to find this angle C, that's this piece up here for the triangle. And then I need to find this side C. Well, angle A is going to be actually pretty easy to find because I know that from this triangle up here, if this is 36.765, that means this guy right here is also 36.765, which means for my angle A in my new triangle, it's going to be 180 minus 36.765. And the reason for that is this is a straight line here, which you know is 180 degrees. So if this is 36, this angle A has to be 180 minus 36.765, which if I do that, I'm going to have 143.235 degrees. So this angle A is going to be 143.235 degrees. Angle C we can find pretty simply now because it's going to be 180 minus 143.235 minus 20, subtracting my other angle measurements, which is going to give me 16.765. So up here I've got 16.765. My side A and my side B are already solved for. So now with this other triangle, I've got to find side C. So sine of B over B is equal to sine of C over C. So the sine of 20 over 4 is equal to the sine of 16.765 over C. Cross multiply and divide by sine of 20, and you get C is equal to 3.373 units. So 3.373 units. Looks pretty messy right there, but I've got two triangles I just solved for. The big red triangle, which is triangle 1, and then the smaller triangle here, which I'm calling the blue triangle, which is triangle 2. I might have to find 12 pieces total. Here I found 6 that were unknown because my A's and B's and other angles were already given to me. But if I look at all the pieces, there are 12 pieces total between those two triangles. So that's the situation where you've got two triangles. If I were to summarize this back on the other sheet here to know when do we have two triangles, the two triangle situation is going to occur when side B is greater than H. So side B is going to be larger than the height, and B is going to be less than A, or that opposite side is going to be less than my adjacent. So when I've got two triangles, I've got two criteria here that I'm looking at. When I had 0 triangles, it was just, is my H going to be large enough to complete the triangle?